Hello, everyone, and welcome back to the Fluctus channel. Introduced in 1956, the first container ship barely carried 58 35-foot containers. Yet, it made a remarkable improvement in terms of handling and transit time. Since then, the container ship industry has grown exponentially. Today, container ships can carry up to 24,000 TEUs and play a vital role in delivering 80% of our needs. In 2013, a new design was developed to build the largest, most cost-effective, and environment-friendly container vessel in the world. The breakthrough design came with a change of process. The hull was designed finer than any other type of the previous vessel. This reduces the resistance of the hull and achieves higher speed, necessary to minimize turnaround time in ports. In addition, the hull of modern container ships is almost rectangular, which allows accommodating a maximum number of containers below deck. Thus, the midship section is designed almost box-like, with a high midship area coefficient, ranging from 0.75 to 0.85. To avoid failure of the ship's hull, the structure is reinforced with a torsion box and high scantling web sections that create a box-like structure at every frame. Ship designers created this giant structure with extreme details and functional considerations. Hence, the container loading plan is created along with the design. Modern technologies allow not only the design of ultra-large container ships, but also the design testing before construction. These would save billions of dollars of cargo and ship. Maritime research institutes, such as MARIN, work on simulations experiments to detect any eventual issues that might cause the failure of different sizes of container ships. The engineers recreate a controlled environments model based on real-life events. For example, the MSC Zoe container loss incident. Typically, the wind current, water depth, and waves are modeled with high accuracy in the model design facility. This led to the conclusion that although container ships are very stable, some extreme weather conditions can induce strong magnified vibrations or high waves, causing the loss of the containers and lashing. Such simulations would determine the required safety design values for future ships. Once the ship's design is tested and approved, the manufacturing process starts. Creating these mountainous ships requires state-of-the-art machinery and intense manual labor. Construction begins with shaping the structure of the ship in sections. Thus, large steel sheets are cut, sized, and then shaped under immense pressure. When the right curve is obtained, the steel plates are welded together to create parts of the ship called sub-assemblies. These are assembled in return to assemblies and ultimately to sections. Then the sections are lifted to a dry dock, where they are welded together to create the structure of the vessel. The vessel is then painted, and a protective coating is added to reduce corrosion. Exterior parts, like rudders and propellers, are created using sand casting, a method that consists of pouring molten metal into a mold and letting it cool. Once formed, the parts are assembled within the ship. Ultra-large container ships exceed 1,309 feet in length and 193 feet in beam, and have a carrying capacity of more than 180,000 TEUs. With a large size like this, it is almost impossible to launch the ship safely with any technique other than the floating out method. Therefore, these vessels are released, utilizing the dry dock on which they are built. Typically, the operators sink the platform underwater along with the container ship. As the dry dock is slowly filled with water, the ship floats simultaneously. The ship's hull is fairly supported by the water, preventing any damage. Before delivering this enormous vessel, the shipbuilder conducts a sea trial, a test during which the overall performance and seaworthiness of the vessel are evaluated. Sea trials are carried out on open water, in the presence of ship owner representatives and governing and certification officials. For instance, the ship might push to the red lines at full load to showcase the class's speed, stability, and other key characteristics. Upon successful sea trial, the ship will be certified and delivered to its owner. Otherwise, the vessel will return to the shipyard for improvement. While container ships have become larger, wider, and heavier, navigating shallow waters and tight canals has become steadily difficult or even impossible, as there is a huge chance that the ship will damage itself or the port infrastructure. Thus, thinking about a tugboat when talking about big container ships is not uncommon. This small watercraft can move ships that are 1,000 times their size. They combine towing and pushing power to maneuver large container carriers in and out of deep water ports. As the CMA-CGM container ship approaches the Savannah harbor, a pilot and tugboats depart the port to assist her through this tight waterway. The captain turns off the engine, the container ship stops advancing under her own power, and moored towing tugboats take the lead. Two tugboats apply immense power to steer the vessel from both sides. A third one controls the ship's speed from behind by a tow line. This prevents the vessel from accelerating. Coordination between the captain, the pilot on board, and the master tugboats are critical to successful berthing. When the vessel finishes its operation, tugboats return to move it away from the quayside and out of the port. The crew on board continue their journey with dedication. They're the invisible hand responsible for moving the global economy. Every crew member is well trained and knows precisely what is expected of him. Day-to-day work is demanding. The crew carries out extensive checks and maintenance work to keep the vessel running. At the same time, all the engineering work is mostly done within the engine room and other critical parts of the ship. The mates on the bridge continuously monitor the vessel's course, position, and speed with charts and navigational aids. It is the captain's duty to ensure that the vessel is operated safely and efficiently. Container ships have many recreational areas, providing the crew with a friendly space for socialization. These containers were also closely tested before release to market. Manufacturers, like Mercic Container Industry, use multiple testing methods, and some techniques might seem crazy. These engineers, for instance, are trying to measure the compressive strength by lifting the container to a virtual vessel height, then releasing it. The container falls dramatically, slightly deforming the walls. The container's design must meet strict requirements. This is essential for the loading and unloading processes at ports. Actually, containers are designed with corner casts that enable perfect alignment on top of each other. To stack these containers on a ship, container forklifts, trucks, and giant cranes are used to move the boxes from the yard to the ship. Once the corner posts are precisely aligned, they are secured using lashing rods. Twist locks are also used to enhance stability and increase stacking capability. Today, some companies add security box locks to their containers. These NFC devices apply about 1.5 tons of locking pressure on each of the 4 locking points. The container shipping industry transports billions of dollars of goods annually in an area of the world that is both serene and turbulent. A small miscalculation might cause a catastrophic event. Therefore, everything from the design and construction of the ship to the testing of containers must be meticulously tested to meet international standards. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.